Hello everyone, my name is Alia Basar and today I am here with a new topic, quadrilaterals. Quadrilaterals you all have done in your previous class. So just recall what is a quadrilateral. So what is a quadrilateral? Any closed polygon with 4 sides, 4 angles and 4 vertices is called a quadrilateral. So there are few pictures over here. If you see a chessboard, it has 4 sides. A TV, it has 4 sides. So any closed figure with 4 sides and 4 vertices, 4 angles is called a quadrilateral. Okay. So the first quadrilateral we are going to study is a parallelogram. So in this picture, ABCD is a parallelogram. So we need to verify that. But can we say ABCD is a quadrilateral? Yes. Why? Because it has 4 sides. Okay. So what is the condition for a quadrilateral to be a parallelogram? A quadrilateral having both pairs of opposite sides parallel is called a parallelogram. So in this, AB is parallel to DC and AD is parallel to BC. Therefore, we can say that quadrilateral ABCD is a parallelogram. So for a quadrilateral to be a parallelogram, the pairs of opposite sides should be parallel. Alright? Okay, let us move forward. The first property of a parallelogram. In a parallelogram, opposite sides are congruent. So here ABCD is a parallelogram and BD is a diagonal. Opposite sides means AB should be congruent to DC and AD should be congruent to BC. So the first property of a parallelogram is in a parallelogram opposite sides are congruent. What are congruent? Opposite sides are congruent. The second property of parallelogram. In a parallelogram, opposite angles are congruent. So here ABCD is a parallelogram. Angle A will be congruent to angle C. Angle A will be congruent to angle C and angle B is congruent to angle D. So in a parallelogram, opposite angles are congruent. The first property was in a parallelogram, opposite sides are congruent, and the second property is in a parallelogram, opposite angles are congruent. Now let us prove that opposite sides and opposite angles of a parallelogram are congruent. We have to prove opposite sides and opposite angles of a parallelogram are congruent. So we have taken a figure. ABCD is a parallelogram. So given quadrilateral ABCD is a parallelogram. If it is a parallelogram, then DC will be parallel to AB and AD will be parallel to BC. What we have to prove? Segment AB is congruent to segment DC. Segment AD is congruent to segment BC. These were the sides and the angles, that is angle D should be congruent to angle B and angle A should be congruent to angle C. Alright, clear? So we have to prove this. Let us see the proof. So we have to do a construction, draw diagonal AC. Okay, we drew a diagonal. So DC is parallel to AC, AB, and AC is a transversal. So here a Z is being formed. So what is a Z? A Z means alternate angles. So angle C will be congruent to angle A. That is why angle DCA is congruent to angle BAC. So angle DCA, the angles within Z are congruent. So angle DCA is congruent to angle CAB. Now if we take AD parallel to BC, what are we taking? AD parallel to BC, and again AC is a transversal. So can you all see a Z? Again a Z is being formed. A Z is being formed. That means angle DAC is congruent to angle CAB. Understood till here? Now we are going to prove that triangle ADC should be congruent to triangle CBA. Triangle ADC, that means this triangle is congruent to triangle CBA. Okay. So we had already seen angle DCA was congruent to angle CAB by alternate angles. So we are taking this from 2. Okay. Now AC is the common side for both the triangles. So AC is the common side, and angle DAC is congruent to angle ACB. That means these two angles are congruent. Let's see this. So that is from 1. So which test will it be? The triangle ADC is congruent to triangle CBA by angle, side, angle. So how to write one-to-one correspondence? If you see over here in middle, A is there. Okay. A with C. So A will come with C. Okay. Then again C with A. So in the first triangle C, the angle C of the first triangle will come with angle A of the second triangle. And the remaining one is, that is, we will write D and B in between. Okay. So just write the name of one triangle, and looking at one triangle, write one-to-one correspondence for the second triangle. So like already written, triangle ADC is congruent to, then we will see angle A is congruent to angle C. So with A we will write C. Angle C is congruent to angle C is congruent to angle A. So angle C will come with angle A, and the remaining D and B will be as it is. Okay. So if two triangles are congruent, then we can say that all the sides and all the angles of that triangles are congruent. Yes. So if the triangles are congruent, then AB will be congruent to DC. Side AB will be congruent to DC. You all look, AB is congruent to DC. AD, that means this side, AB will be congruent to BC. Okay, CB can be written as BC. Also angle D. So angle D over here, it is in middle. So which one is in the middle? B. So angle D will be congruent to angle B. Okay. So by corresponding sides of congruent triangle and by corresponding angles of congruent triangle. Okay. But what about the second angle? So if you see the second angle, from here we have got angle D is congruent to angle B, right? So for these angles, to prove angle A is congruent to angle C, what we have to do? We have to draw a diagonal BD, and then we have to prove that triangle ADB should be congruent to triangle DCB. Okay. triangle ABD should be congruent to triangle DBC. Once we prove that, then we can say that angle DAB is congruent to angle BCD. Clear? So a quick revision. So we have to prove that opposite sides and opposite angles of a parallelogram are congruent. We will take quadrilateral ABCD is a parallelogram. If ABCD is a parallelogram, then the opposite sides will be parallel. So AB is parallel to DC and AD is parallel to BC. So to prove that AD is congruent to AB and AD is congruent to BC. So we took two triangles, triangle ADC and triangle CBA. In triangle ADC and triangle CBA, so with the help of alternate angles, we showed that angle C is congruent to angle A, and by taking AD parallel to BC, we showed DAC is congruent to ACB. Now in these two triangles, we got two angles and one side. One side is AC, which is a common side. So once the two triangles are congruent, if two triangles are congruent, all the corresponding sides and angles are congruent. Therefore, by corresponding sides of congruent triangle, we said AB is congruent to DC and AD is congruent to BC. Alright, and angle ADC is congruent to angle CBA. We have to write similarly, we can prove DAB is congruent to BCD. We can show it by taking BD as a diagonal and showing DAB, triangle DAB is congruent to triangle BCD. That we need not to write, but we can show it that way. Alright. Okay. So let us see the examples on the theorem which we studied. So quadrilateral PQRS is a parallelogram. Then find the value of x and y. Okay. So the property was, for the sides, the property was opposite sides of a parallelogram are congruent. So here it is given in the diagram. PQ is 6x. Sorry, it will be 6x minus 8. And PS is y minus 2. SR is 3x plus 10 and QR is 8. Solution. So PQRS is a parallelogram and PR is a diagonal. So PQ will be equal to RS. If we take PQ is equal to RS, PQ is 6x minus 8 is equal to 3x plus 10. Then we will shift variables to one side. We will transpose variable to one side and numbers to the other side. Okay. So it is 6x. It is 3x on the right hand side. It will move and become minus 3x, and minus 8 will be transposed and will become plus 8. Okay. So 6x minus 3x is 3x and 10 plus 8 is 18. So x become 18 upon 3, which is x is equal to 6. Alright. Now to find the value of y, we will take PS is equal to QR. Opposite sides of a parallelogram are equal. PS is y minus 2 and QR is 8. So y is equal to 2 will be transposed. So y is equal to 8 plus 2, that is y is equal to 10. So our solution is x is equal to 6 and y is equal to 10. Clear? Okay. Now example 2. In the adjoining figure, angle D is given as 85 degree and angle B is given as x plus 25 degree. We have to find the value of x. We will write given angle D is 85 degree and angle B is equal to x plus 25 degree. What is the solution? Opposite angles of a parallelogram are equal. So angle D will be equal to angle B. Now angle B was x plus 25 degree is equal to 85 degree. 25 degree will be transposed. So 85 minus 25, that is x is equal to 60 degree. We got the value of x as 60 degree. Okay, that was asked in the question. Now if we have to find the value of B, what we will do? We'll substitute x in B, that is 60 plus 25. So angle B will also be 85 degree. Okay, It had to be 85 degree, right? Because opposite angles are congruent. Alright, clear? Let us move ahead. So now the two properties are done. The first property was opposite sides of a parallelogram are congruent, and the second property was opposite angles of a parallelogram are congruent. So the third property of a parallelogram is, in a parallelogram, diagonals bisect each other. Okay, so let us consider ABCD as a parallelogram. Over here the diagonals are AC and BD are the diagonals. The diagonals bisect each other, that means they divide it in equal parts. So they are intersecting at a point O. So AO is congruent to OC and BO is congruent to OD. Okay, so the diagonals bisect each other, that means they divide them into equal parts. Okay, so let us see the proof of this theorem. So we have to show that diagonals of a parallelogram bisect each other. We will consider a parallelogram ABCD. What is given? Diagonals AC. Quadrilateral ABCD is a parallelogram. Diagonals AC and BD intersect each other at O. Now what we have to prove? We have to prove that segment DO is congruent to segment OB and segment AO is congruent to segment OC. Alright. Now to prove this, over here DC is parallel to AB and we are taking AC as the transversal. Can you all see a Z being formed? That is by alternate angles. So the angles inside this Z, that is angle C, will be congruent to angle A. Okay, and if we take DC is parallel to AB, but this time the transversal will be BD. If BD is the transversal, then angle CDB will be congruent to angle DBA. Again, this is by alternate angles. Now we have to prove that the diagonals bisect each other. So we have to consider a triangle which has the diagonals that are being bisected, yani with O. So we will take triangle DOC and triangle BOA. So in triangle DOC and BOA, angle DCO is congruent to OAB. This is different name of the same angles. Yes. And angle CDO will be congruent to angle OBA, different names of same angle. And if we see CD is congruent to AB because CD and AB are opposite sides of a parallelogram. So by which test the triangles will be congruent? Angle, side and angle. So by angle, side, angle test, these two triangles are congruent. Clear till here? Now if the two triangles are congruent, that means segment DO, by one-to-one correspondence, segment DO will be congruent to BO and segment OC will be congruent to segment OA. Okay, by corresponding sides of congruent triangle. Clear? So to prove diagonals of a parallelogram bisect each other, we will take a quadrilateral ABCD, which is a parallelogram, and we have to show that OD is congruent to OB and AO is congruent to OC. So here we are considering two triangles, triangle DOC and triangle BOA. So two angles we are getting by alternate angles, and one is a common side, opposite sides of a parallelogram. So by taking opposite sides of a parallelogram, so by angle, side, angle test, we prove that the triangles are congruent, and if the triangles are congruent, then all the corresponding sides and the corresponding angles should be congruent. So over here we don't need angles, so we just took segment DO is congruent to segment BO and segment OC is congruent to segment OA. I hope it is clear to you all. Alright, let us see application of this sum. So the example 3 for today. Diagonals of a parallelogram WXYZ intersect each other at O. If length of OY is 5 cm, then length of WY we have to find. So, okay, WXYZ is a parallelogram, and WY and ZX are the diagonals which are intersecting at point O. We are given OY is 5 cm, we have to find length of WY. How can this be done? So given length of OY is 5, we have to find length of WY. So we know the diagonals of a parallelogram bisect each other. That is, OY will be half of WY. Since they are bisecting, that means OW is equal to OY. Yes, so OW plus OY will be equal to WY, but these two are equal, na? Can we write it? We can write it as twice. So OY is equal to half of WY. So substituting OY, 5 is equal to half of WY, we get WY as 10 centimeter. So the value of WY is 10 centimeter. Clear? Okay. Now these are the links of GeoGebra for test for understanding. We will visualize all the three properties using this links. Okay. So let us visualize the properties which we had studied. So the first property was that the opposite sides are congruent. So if you see here, ABCD is a parallelogram, AB and DC are the opposite sides. What is the value of AB? 5.5444, and CD is also 5.54. If I try to change the size of AB, look, I made it short. So AB now became 3.54. So CD also changed to 3.54 because the opposite sides are always congruent. If I try to change AC, look, it is 5.66 and BD is also 7.66. You'll see if I change this vertex, the values are changing. Look. So we can say opposite sides are congruent. Okay. To visualize the second property, opposite angles are congruent. Over here, the measure of angle C is 129.08 degrees and the measure of angle, do you all want to check the measure of angle B? So checking the measure of angle B, it is also 129.08. Alright, look, now I'll try to change it. So C becomes 112.19. So B also becomes 112.19. Let us check the measures of angle A and D. Angle A is 67.81. Angle D is also 67.81. Now it is 68 and 68. Okay. So the opposite sides are congruent, and in this we had seen that the opposite angles are congruent. To visualize the third property, diagonals bisect each other. Over here, again, ABCD is a parallelogram. What is the measure of OB? It is 4.27. So the measure of OT is also 4.27. Let me change it. Look. Now OB is 5.3, so OD is also 5.3. And if you see the diagonal AC, so OA is 4.18, OC is also 4.18. I try to change this. Look, 2.98 and OC also becomes 2.98. So I hope it is clear.